This is a simulation that explores the reflection and refraction of light waves. I actually think of it more as an animation because there are a few things you can control about this, but more it's a movie to show us a picture of what's happening when a wave moves from one medium into another. And it is also used to explain something called the Huygens Principle. We didn't really delve into that in this class, but if you read elsewhere, you can see that the Huygens Principle involves assuming that all points where a wave encounters act like little tiny point sources that absorb a little bit of the wave and then re-emit it in all directions. So right now this is showing us a plane wavefront that runs diagonally across a boundary between two media. So it's moving within medium 1 and it's not yet showing us what happens in medium 2. The simulation kind of builds up in complexity. A wave front is what you get if you trace a line along all points on a wave that have the same height. So if you think about being at the beach, the crest of one wave that's coming in would be considered a wave front because all the points along that line have a similar height of that water wave. So that's that piece, and in the next step we put a whole bunch of little point sources along the boundary between the mediums here, and they are going to absorb a wave and then re-emit the wave in all directions. However, you may be able to pick up from this that in this particular simulation, the waves travel faster in medium 1 than they do in medium 2, and that results in some differences here. In the next step of the simulation, we draw the actual reflected plane wave. So here's the incoming plane wave, but notice now that when it's being reflected at all of these point sources, they're drawing a new wavefront line along the fronts of all of those created waves from each of the point sources that creates the new wavefront. And so the reflected wave is at that same 45-degree angle that the incoming wave was, but the new wavefront is at an angle of 20.7 degrees, so a much smaller angle in medium 2 due to that change in speed. The next thing, same simulation, but now we're drawing the rays superimposed over the wave fronts, because rays are rather a simplification of what's happening here when we just focus on one particular path along that wavefront of light. And so the ray picture looks very similar to what is seen on the Fendt simulation when you move the light source and move the rays. And here it's just being superimposed on this simulation of wave fronts. The final step in this particular simulation is to show that usually you don't get a single wavefront coming in. There are many wavefronts, and so this is going to keep the simulation going by having several wavefronts interact with that boundary between the two mediums, and they're going to create in turn several reflected wavefronts, which are reflected at the same angle and have the same wavelength in medium 1, but the ones in medium 2 are refracted at a different angle, and the wavefronts are closer together, which is evidence that the wave is moving slower in medium 2 than it is in medium 1. But the screen gets pretty busy here at the end, which was why they designed this to build from the ground up.